Hello again, Year 10, new week, new topic. I will be putting up a knowledge organiser page for this onto Teams because this is actually a Year 11 topic that we've moved around and has changed the teaching order due to home learning. Now you've got a do now on the front, which is a little bit of revision which will help us be ready to start this unit. You have got 3 types of bond you need to name. I've been really kind. I've given you the first letter of each type of bond. And for each of them you need to say what type of atoms are they formed by and how are electrons involved. Obviously, while you do this starter, you will probably want to pause the video. Right, checking your answers. You have got metallic bonds between 2 metal atoms. They can either be the same type of metal or they can be 2 different metals in an alloy. Remember that word, I'm sure. They use shared moving delocalized electrons that are fluid. That gives the metal some of its properties, such as the fact that it will be able to conduct electricity. Ionic bonds are formed between a metal and a non-metal, and they result from the movement of electrons from one to the other. Covalent bonds are between 2 non-metals and you have pairs of shared electrons. Sure you're all good on that? If you're not, you need to go back and revise it because it's something that will always come up in your GCSEs. Right, objectives for this unit of work. To know what crude oil is made of, to know what an alkane is. That's a new word, you need to learn it, you need to be able to spell it. It's really important you get the spelling right, A-N-E, because there's another type of compound that's very similar. It's got a different spelling, E-N-E, and if you get the spelling wrong, then everything else will be wrong. So that is a really key word to learn the spelling of. You have to be able to show how chemical and displayed formulae work for alkanes, and you have to be able to name them, only a few of them. You have to know how the parts of crude oil could be separated, and we are also going to practice recognising a trend and writing a general statement using as for our start and then increases or decreases to compare the properties that we're using. Now, hydrocarbons, one of the easiest terms you'll ever come across in chemistry. They are made from hydrogen and carbon. It's easy as that. Everyone's breathing a sigh of relief going, well, yep, we can do this. Hydrogen can make 1 bond, carbon can make 4 bonds. That's really important. If you can count up to 4, you're good for this. So I know you will all be good. And they can make either chains or they can make rings. And some of these structures can be really, really long, and that will affect the properties. They include the fuel that you use to power vehicles, that's petrol and diesel, and also oil that can be used to heat your home. Some of you probably have heating oil or know people that have heating oil rather than having gas or electricity. Many of these chemicals are contained in a mixture that's called crude oil, and that means crude in the meaning that it is untreated, it is a raw ingredient. Remember, when you have a mixture, the parts are in the same sort of space, but they are not chemically bonded. If, for example, if you were to mix salt and sugar in one container, you would have separate parts of salts and sugar. They wouldn't ever join together, have a chemical reaction, but they would just be in the same space. Now, we're looking at alkanes in a bit more detail. We are going to have this table to copy and complete, so you will want to pause the video while you do this. Most of the hydrocarbons in crude oil are alkanes, and the start or the prefix part of their name tells you how many carbon atoms there are. So you learn these and you can learn a lot of chemistry at the same time. If you've got meth and you've got ane at the end, A-N-E, because it's an alkane, that's got 1 carbon atom in it. Eth, you can add the ending to make the whole molecule name, has 2 carbon atoms. Prop, you finish it off, has 3 carbon atoms, and bute has 4 carbon atoms. That's quite straightforward, but you do need to learn these, which is why you're going to copy and complete that table. Now, this weird stick structure here is called the displayed form. So instead of just writing the elements involved and the number of atoms, we can actually draw a diagram to show the form of a molecule. So you can see you've got 1, 2, 3, 4 arms. Remember we said carbon makes 4 bonds, but each of them has only got 1 hydrogen. Hydrogen can only join to 1 carbon because it can only make 1 bond. And they're equally spaced at right angles to each other because of the forces involved. And this is methane. It's got 1 carbon, 4 hydrogens shown like that. Now you have already got the formulas for ethane, propane and butane in the table you've just drawn, and you're going to use those formulas to draw the molecules out. So first of all, start with the carbons. They will each join onto each other. So ethane has 2 carbons, so you'll have carbon, 1 line, join it to the next carbon, and then fill the other arms with hydrogen. Same for propane, same for butane. And because of that, you do actually get a general formula. This is something you will have done in maths when you're looking at a series. And you're looking at the formula for a series, and obviously you can get far, far longer molecules than we're looking at today, but I'm not going to be mean and make you draw something with 25 carbons. Although you might like the challenge, I'm not sure it'd be the best use of our time. So if you've got n atoms of carbon, then you'll be 2n plus 2 atoms of hydrogen. Sounds a bit weird, but think about it. You've got 1 carbon here, so 2 lots of 1 is 2, and then there's 2 more. If you have 2, you have 2 lots of 2 is 4, and 2 more is 6, and so on. That actually lets you go backwards as well, and if you know how many carbons or how many hydrogens are, you can work out what the whole molecule is. Worth practicing that. So while you draw that formula out as an example, and then your other 1, 2, 3, you will need to pause the video. Now we're going to think about the properties. Properties are used to compare a group of elements or compounds. So what's similar, what's different, how quickly one thing changes, whether things relate to each other. We've talked about properties when you have groups of element. You talk about going down a group in the periodic table. I'm sure you remember that. And now we're looking at properties for alkanes. One property is the size of the molecule, whether it's got a long or a short chain. So that'll be related to how many carbons are involved. The boiling point, volatility. This is a word you need to know. You might well have seen that. You might have heard of paint having low volatile compounds in it so that it doesn't smell so bad. That's how easy it becomes fast. If something is very volatile, you can make a smell quite easily. Viscosity, how easy it flows. This is something that you will see labelled up on oil that you put into the engines of cars and motorbikes, because they are there to make it easier for parts of an engine to move past each other. Flammability, how easy it burns. You may well see warnings to do with some of these at places where you will have hydrocarbons such as petrol stations. Now the last one on the list, boiling point, volatility, viscosity and flammability, all depend on the first one. So the length of the molecule decides on the other properties. And here's our practice question where we're going to write the general statement coming up. Now we've got a long list of alkanes. Some of them you already know. Some of them we haven't already looked at, but you will already recognise the prefixes from maths. So pent, you'll know what a pentagon is. Hex, you know what a hexagon is. Hept, again. So these are quite straightforward. If you're not sure, you can look online, but I'll give you a clue. Dec, as in decimal, is 10. Dodec is 12, so I'm sure you can work out what undec is in between. Yep. So, number of carbon atoms and the boiling point. You are going to work out the number of carbon atoms, you're going to work out the boiling point, and then you are going to write a general statement. You've got the 2 bits of information you need to reference are actually the headings in the table. So you'll say as the number of carbon atoms, and it will be either increases or decreases, the boiling point of the molecule, and that will be either increases or decreases. It's not too tricky. I'm fairly confident we can do this really easily. You may well want to copy out the table and pause the video while you do it though. just in case you're getting bored of hearing my lovely voice talking to you, we have now got a video clip. And this is all about fractional distillation of crude oil. Distillation is when you use boiling point to separate a mixture of liquids. You have seen it used to separate ethanol in water using a Liebig condenser, I'm sure. You have got 5 questions here on this side which you will need to answer from the video. So I would suggest that before you look at the video, you pause this, you write your 5 questions, leaving 1 or 2 lines for each, a little bit like a structure strip. Then you watch the video and you fill in the answers to the questions. I'm going to admit I have been quite kind. I have put the questions in order. But that does actually mean obviously you need to get to the end of the video. One more thing for you to do. You have got a diagram of a fractional distillation column here. You'll recognise that from the videos you've just watched. You've got labels that go with it. This is quite often a question that will come up in tests or exams, which is why I've got it for you to practice. There is also a printable version of this on Go for Schools. If you're finding this is a little bit small, there's a print version that you can print out, or you can put it into a Word document to play with it yourselves. You will need to use all of these labels, and I haven't put the answers on. I'll put them up next week. And finally, you've got a quiz. It's a bite-sized quiz. This link will take you directly to the quiz page. If you find it a bit tricky, you might want to go back and review the previous pages on bite size. I do want you, when you have done the quiz, to take a screenshot showing me your score and submit that to me on Teams so that I know that you've got to the end of the work and you've got it. Obviously, if you get questions wrong, I will expect you to have made notes on why you went wrong and to have sorted it out. Any queries, any problems, you know how to find me. Take care, enjoy being back at school, and hopefully see you soon. Thank you.